Greetings, class. Today, the first problem I want to take a look at is one that's called a superposition problem. Superposition problem. Here, we'll write out superposition. If I can spell superposition. That's when you've got usually three charges. These are all going to look the same, but there's going to be three charges. And if you place the center one in the field just right, it should go static. Take a look at in your problems, superposition. It's problem C that I've got listed out there. You've got three charges. You've got a positive Q2 charge. You've got a negative Q3, and you've got a positive Q1, and all of those lie within the same plane. Alright, so now let's just take a look at this. What we're going to have here is this is a positive, this is a negative. That means there should be a force of attraction. So in this direction, there should be a force of, we'll say, 3 on 1 attracted between those two objects. And this is a positive, this is a negative. That means we should also have a force 3 on 2. And somewhere inside this field, if you get just perfect, this object should get in equilibrium. So the basis behind a superposition problem, and again, I haven't even read the problem, I'm just looking at the picture. The basics behind a superposition problem is that these two forces should equal. So the force of 3 on 1 should be equal to whatever force is present between 3 on 2. Now, it's given us some numbers here. We know that these two are 2 meters apart. And apparently what we're looking for is this x, which the big key is that means that this distance, this is the key to the problem right here, is when you do this. The distance from here to here is 2 minus x. And really, that's the key to the problem, writing that out. Because now, look, you know the equation for force. It's K QQ over R squared. See if I can get these forces. Q1 is 15 micro. That's 15 micro. Let's see, Q2 is 6 micro coulombs. Where must a negative charge Q3? Do you notice how it doesn't give us a charge for Q3? Well, if you're thinking that that should cancel itself out, then congratulations, you're thinking right. So that's why it hasn't given us what that central charge is. It really doesn't matter. So let's start writing this out. This is going to be K, Q2, Q3 over distance from here to here is giving us x squared, and that's going to be equal to K Q3 Q1 over here over, now here's the big thing, Q3 and Q1 are separated by a distance of 2 minus x. So 2 minus x square. Now take a look at what happens. This K cancels, that K cancels, this Q cancels, that Q cancels. So the only thing we're left with now is Q2 over x squared equals Q1 over 2 minus x squared. The problem is basically done. All we've got to do now is the algebra and solve it for x. Let's go ahead and bring this over. So this is Q2 times 2 minus x squared equals Q1 x squared. So now, I'm going to go ahead and plug in my values. I want you to look at this. Q2 is 6 micro, 2 minus x squared, equals Q1 is 15 micro. And what's nifty about this is the fact that even the micros cancel. So that's simplified this down now to just 6 and 15. Now we're going to have to full this out, is what we're going to have to do next up here. So let's full this out. So this is going to be 6 times, let's full this square. So that's 2 minus x times 2 minus x equals 15 x squared. If you want to, we can go ahead and get rid of the 6. We'll take 15 and we'll divide that by 6. I didn't even think about that and just go ahead and get rid of it. 15 divided by 6 equals 2.5. So we'll divide that, but let's full this first. 2 times 2 is 4 minus 2x minus 2x plus x squared equals 15 divided by that 6, 2.5 x squared. Push this up a little bit. Alright, let's start getting this down a little bit. Now we've got 4 minus 4x. Now this is 1 minus 2.5, so minus 1.5 x squared equals 0. Now I know it's turned out kind of backwards, but in the end, oh wow, my fingernails are kind of, it's not really that they're that dirty, it's just the way they're laying. Shut up. Now, take a look. 4 minus 4x, we've got a quadratic. It's just laying out backwards. So there's our A value, there's our B value, there's our C value. Plug that into our trusty Casio. Mode 1, 2 degrees. A is negative 1.5. B is negative 4. C is 4. We've got negative 3.4 and a 0.77. So our answer, x is equal to 0.77. So x is 0.77. So that means in that initial drawing, this is 0.77. And it also means that this, on the other side, except I'm still in the wrong mode, shift mode 1, mode 1, there, 2 minus 0.77, why did I do that in the calculator? And that is the basics behind a simple superposition. The only thing that kind of stinks, this is a really important question for you to learn. It's just that the only one in the book was number 16. So go ahead and do number 16. It's a superposition. Maybe go back and redo this one even, because I need to give you a quiz on this. Is one that needs to be committed to your person, because I mean this is one that you need to know how to do. I know it seems kind of simple, but I guess the reason why there's only one example of this problem is just because it's the same thing every single time. Every superposition problem is the same. So in the sense, I guess there's no reason to give you more than one, because it will still be the same question. So anyway, have fun with that superposition problem.